Being connected is essential. It is estimated that by 2020, an individual will own 6 devices on average, which include smartphones, MP3 players, tablets, laptops, and even devices synced onto cars. Keeping track of the battery life of all these devices becomes really hard. To solve this problem, we present our BatterySync app. This is Swapnil, a student at Georgia Tech. He owns a phone, an MP3 player, and a tablet. While in class, Swapnil dreams about working out at the campus recreation center while listening to his favorite artist. After a long day at school, Swapnil gets home. He is now ready to leave for the CRC. However, he realizes that his MP3 player is not charged. Swapnil now has to wait for about 15 minutes for his MP3 player to charge. The user owns 2 devices. The phone is displayed to the left of the screen and the tablet to the right. On his phone, the user logs in to view all his devices that are synchronized by the BatterySync app. The list of all his devices, along with their battery levels, is displayed in ascending order. Clicking on a device displays the list of all running services and applications. Using the green toggle switch, the user can choose to turn off a service or application and thus conserve battery life. For example, the user wants to turn off Bluetooth on his tablet. As seen here, the Bluetooth on the tablet is turned off by the BatterySync app. Our app also gives a notification if the battery level of a user device goes below a certain threshold. Clicking on the notification redirects the user to the list of devices. With the BatterySync app, his dream is interrupted with a notification on his phone. He finds that his MP3 player has only 30% charge left. Swapnil then decides to turn off all the running applications on his player using our app. He does not have to wait for his MP3 player to charge anymore. Logically, our system is divided into 4 components. The user interface and actions are taken at the client layer. The client layer uses the API provided by the operating system to get system-related information and to use system services. Through the operating system layer, the client communicates with the server using HTTP messages. The server also uses MySQL databases for storing the user data and to respond to user requests.